Hey everyone, this is Matt with Learn Everything About Design, and in today's video, we are going to do sort of a wrap up on this AirShaper project. I could go on and on forever talking about little design changes and rerunning simulations, but for the purposes of this project in general, I'm going to wrap it up today, and we do have plans to do more AirShaper content in the future, and I'll talk a little bit about that as well. But for right now, what I want to do in this video is I want to talk about the big takeaways from the project, which are things like ease of use, compatibility with models, the solves being off of your system, and auto-generated reports and images, things like that. I also want to talk about what I learned from you doing this AirShaper project, final changes that we made to the model. I'm going to talk about things like next steps, what I would do from here as we continue. And I also wanted to talk a little bit more about things like the pricing structure of AirShaper. Make sure that we understand how much it costs, how it works, and what happens when you run out of credits, when you're doing solves and so on. So in this video, we're going to talk about all of that. I'm going to talk about the licensing plans, the consultancy, and all of that. But again, it's important to note, I'm not an affiliate for AirShaper. There's no affiliate link. There's no discount code. If you buy it, if you don't buy it, that doesn't have an impact on me or the channel. But I was given the opportunity to try it out after we did a previous simulation video using SimFlow, at least the free version of SimFlow. And I've used CFD before with other packages. SolidWorks CFD was probably one that I've used the most in the past. And so I'll talk a little bit about that as well. Things like pricing structure and the differences between the cost of AirShaper. Now, when we think about the cost of these different software packages, I know a good portion of this channel is like hobby Fusion license users. And so you have a free license. Or if you are using things like Plasticity or other programs, it could be any program as well. But I do really want to talk more about some of these professional solutions and the cost and so on, so that we really have a good understanding as to what you get when you're using something like the free version of SimFlow. And I'm going to talk a little bit about their pricing structure as well. But then how that differs from something like AirShaper. So if you're interested in CFD, car, plane, boat, all these different types of simulations, and you want to know more about AirShaper, hopefully this video will answer those questions. Now, from that last video, we did have questions about things like accuracy to other simulation programs. We had some questions about the cost and those sorts of things. So I'm going to try to answer all that today. If I miss anything, please leave a comment, let me know, and I'll do my best to answer it. All right, so first things first, let's talk about big takeaways from the project. Now, in the last video, we went through the setup process and I talked about how easy it was. That alone should have helped you understand, but if you didn't see that, then the first thing is ease of use. So when you're going to set up a simulation, if we start a new simulation, it's really straightforward. You've got three different options: an analysis, you've got optimization, which this actually will allow AirShaper to change the shape of your model, and then you can download an STL after that. And then there's a beta here for internal flow. So if you're doing internal flow design, you can do that. I'm not going to walk through the setup process because we've already done it, but it is extremely straightforward. I haven't used any other simulation of any kind that has been as easy to set up. And so for this project, that ease of use is extremely beneficial. And that's because most of us aren't CFD experts. To be a CFD expert, you really need to go to school, get a master's degree, and have a very good understanding of a lot of mechanical systems, materials, and failure modes, and all these sorts of things. If that's not you, like it's not me, then programs like AirShaper really bring the ability to do this type of work to a broader audience. You don't have to spend nearly as much as you would to get a full-blown CFD package with another supplier like SimFlow or like SolidWorks or like any of these other systems like ANSYS and so on. And if you go digging around into some of those, and I'll go ahead and look CFD simulation, and let's just see what comes. I didn't even spell it right. Let's try again. I can spell, I promise. Let's see, simulation. All right, so if we look at this here, you'll notice that we get ads for here's EngineSoft, SimScale, and I've used SimScale in the past, which this is another one where you can you if I remember right, SimScale is one that you don't have to actually mesh. It works off the solid model, which is pretty interesting. ANSYS here, we've got Siemens, CFD software, and so on. And so when we look at these, there are dozens of different options. And OpenFOAM in the back end is behind things like SimFlow and a lot of these packages that we're finding that are web-based as well. And so there's a lot of different programs that you can get access to. Most of them will have a really high barrier to entry. While programs like SimFlow have that free version, which is a very limited number of cells to solve, low resolution mesh, most of them you are going to be in $8, $10, $15,000 to get started. Now, while most of these are going to solve locally, sometimes they'll be able to solve across multiple cores. It will be a system resource problem. And obviously Fusion has simulation as well, but Fusion doesn't have flow simulation. It does have thermal, but it doesn't have thermal flow. And so that is a big distinction that we should understand. All right, so there's a lot of different programs out there. In most cases, they're going to be very expensive. I'll talk a little bit about pricing in a bit, and very hard to use. It is a dedicated engineering software, and you need to have a pretty high level of knowledge to make it work. AirShaper removes that barrier almost completely. It walks you through the setup, a handful of clicks, and it's dedicated to very specific types of CFD setups. So if you're doing car, if you're doing airplane, if you're doing these types of things, motorcycles and so on, it is made for that, and it is very easy to set up. So that ease of use is 100% a big selling point for me. Number two is compatibility. Now, in many cases, not all cases, but in many cases, when you are doing a CFD simulation, you have to have a sealed watertight model. And then you create what are called lids that dictate inlet and outlet flow. So if you're doing, let's say, flow through a computer, like a CPU tower, and you've got all of this venting on the front, and you've got fans on the back and so on, this becomes a really complicated setup problem. And then if you've got models that are not all native CAD geometry, if you've got some mesh data, it won't work. In many cases, it has to be CAD geometry. Otherwise, it needs that to be able to mesh for itself. Now, AirShaper is different because you can bring in meshes. You can have non-watertight models, and you can deal with these sort of like open areas, and you can use scan data and so on. So that is, again, that's another selling point. So ease of use, and then the compatibility with all these models. Because there have been times when I've set up simulations where you really have to spend a lot of time prepping the model, like removing microfillets and chamfers from a production model, and removing details that are going to be non-essential to the final result. And spending that time, I mean, anywhere from an hour to 4 hours on a typical model is common. So again, removing that and simplifying the compatibility of models is, again, a huge benefit. So you can get started right away. You can set up in a couple minutes, and you can have a result in a couple of hours. And that's because it doesn't solve on your local system. So if you were to try to run a big simulation from ANSYS or from SolidWorks or from any of these, these other local programs, then what's going to end up happening is it's going to be cooking your CPU, it's going to be using up your RAM, and you pretty much are not going to be able to use your computer. The way most of these computers work is that initial core in your system. What that does is it's going to be using that single core for if you have your email open, if you have a web browser open, and it's going to be sharing those resources. So it really doesn't make sense unless you have a dedicated system to make that happen. All right, so that takes care of ease of use, compatibility, and the quick solves. The last thing is the auto-generated reports. So here in 3D, we've got 3D images we can rotate around. This is something that when you're setting up a simulation, and I'm going to compare it to SolidWorks here, when you're setting up a simulation, you generally will create these sort of inspection items that you want to follow or track while it's solving. When it's solving, it's going to go through this process where it's going to go through and iterate until it normalizes or feels like the results are within a range, sort of this basically this error range. And once it feels like they're not going outside of that, above or below, then that's kind of a normalized model. And typically this takes thousands of solves, thousands of times running through this. And when we think about solving and setting up a resolution, like the number of cells that we have, this is going to calculate basically what's happening into and out of each of these cells. So when we do simulation and we have a mesh on a body, it has to calculate what happens at each of those locations. And so the number of cells and basically the size of the boundary all have this impact, and then it continues to run these until it normalizes. So, excuse me. And so with that process, that takes time. But you can set up these inputs or these sort of things that you want to track on the front end, like pressure and flow, and then watch those as it's going through this. And you kind of get a general sense of what's going on. Now, obviously, these take hours to solve, so you're not going to sit there the whole time. And then on the outside of that, like once it's solved, then you need to generate these things, cut plots and flow lines and all this stuff, and create your reports. AirShaper kind of removes all that for you. And so you get emails when you set up a simulation, when it's solving, when it's done. And then you can come in and take a look at the info. You get your forces, you get how many times it went through to converge, how many cells you have. And this, again, it just kind of removes that altogether. Now, do you possibly want some more advanced settings? You can do that on the simulation setup, depending on which plan you have. But for the most part, I think that probably 99% of people are going to use these standard settings, so it kind of removes all of that complexity from it. So from the setup, the prep of the model, again, scan data, mesh data, non-water tape models, the efficiency of the solves, generally they've been 2 to 4 hours for all of my solves, and then these auto-generated images, 3D models, and reports. That takes away a huge portion of doing CFD. I mean, it probably takes out half of the work for you. All right, so all of those things are kind of the big takeaways from this project. So if you're looking to do CFD on a car or an airplane or something like that, then just going through that process, trying this out is something I would suggest, especially if you're considering buying another CFD software. All right, so what did I learn from using this? It took the guesswork out for me. I'm not a CFD expert. I've used CFD. I've done CFD for clients. Typically, I have done that at the direction of a PE, a professional engineer. And that's a lot of times what you'll find in industry as well. So you'll have somebody that sets up and runs simulations, and then you'll have somebody that checks them and validates them and so on. And this process is kind of iterative. And so I'm not the person to validate it and say, yes, that bridge is going to be 100% correct. But I've used it enough that I have a basic understanding on the setup process for most programs. And with that, again, it just took the guesswork out. Like I didn't have to worry about understanding certain aspects of the CFD setup or results process because it's just done for you. The results, for me at least, excuse me, helped me narrow down design changes, right? So I could look at design changes. I could look at areas where we've got, red or blue and kind of say, okay, well, pressure's high, pressure's low here, or the surface friction is high, surface friction's low. We can make changes. So you can see this like red and yellow here. We can make changes to the shape if we want to increase the car's ability to kind of slip through the air. There's too much friction in this area. And those are, again, visual changes that we can take a look at and see. Now, if you have trouble with understanding these, then using the consultancy option is something that AirShaper has that I haven't seen any of the other CFD softwares offer directly. And so this allows you to use credits, again, the credits that we use to solve these, it allows you to use those credits towards a personal session with an engineer that can walk you through things like results, give you ideas on what you could change in your model to increase performance and so on. And so again, having that ability where you can go in as a novice user and you can set up a CFD, you can look at the results, make changes. And if you get to the point where you're like, this isn't really working very well, I don't know what I'm doing, you can do a one-on-one session, a web session, remote session, where you get expert advice walking through understanding the report, understanding the results, and then saying, okay, well, here are some things that you could change to make this work better, right? And I was actually thankful enough to have that experience. I was given the option to use AirShaper, have some credits to play around with, and also got that direct feedback where I was given some design advice on, okay, hey, you should change these areas. So, for example, these airflow channels that are coming from the front of the vehicle and trying to get that 3D pressure cloud away from the quarter panels. As you look inside here, you see there's red on this side and there's blue on this side. And so typically what we're looking at here is areas of high friction and areas of low friction. And seeing the red and the blue, and especially down here as well, so red and blue, these kinds of things allowed me to, through the consultancy, allowed me to understand, okay, well, this means that I should really change the shape of the way the air flows, because we've got these low pressure sections. This basically means that air is not moving there, right? Or high pressure sections mean that maybe I should smooth out this corner rather than having it come around the corner. I can change it so that the corner itself stays more gradual, coming out to the side of the vehicle. And so again, if after probably one session of going over some simulation results, you'll probably have all the information you need to help with that. Now, as far as I understand, they don't offer like 3D modeling services, but just getting the direct impact from looking at your own simulation results and getting some feedback on, hey, here's what works, here's what doesn't, here's what you should change. One of the big things that ended up changing is the roof line for me. All right, so on this one here, the roof line was pretty hard, and that's what we typically see with 80s cars. That was the inspiration for that shape, right? And so when we go to the final one, this was rounded off to try to reduce that sort of hard edge and keep everything flowing more smoothly over the top of the vehicle. Now, the front still stayed fairly hard, but once it gets past that point, the transition all the way back to the spoiler, those changes were made, something I probably wouldn't have done. But just having that feedback from looking at the results, having that sharp corner there actually led to air separating away from the vehicle and coming back. So once there was a spoiler there and we're trying to manage the downforce, having that feedback again was helpful by using the consultancy. And again, the consultancy is based on credits. So the low res solve is typically 1 credit. The sort of medium, which is most of the ones that I did, were 10 credits, and an hour consultancy is 10 credits as well. So just keep that in mind. That isn't an available option. It's something that I don't think most other CFD programs have. And again, this started with very low resolution solves. So those 1 credit solves to get a good idea as to what's going on. And then once I had some feedback from those low resolution solves, then we could move into the higher resolution. And they were fairly accurate. When I say fairly accurate, there is going to be a level of difference between forces that you'll see, the same exact model solved in low and medium res. And that's because you get higher resolution, you get more cells around the car. The mesh model is a higher density. And so it's more accurate to the original concept. So things like, so for example, meshing the wheels, you can see it. I had a very tight distance between the tire and the wheel well. Now, in reality, those are not connected, but because of the resolution of the mesh, you can kind of see that they end up being connected. Whereas the higher resolution, I'll go back to the pressure cloud, you can see that we actually do have a gap between them. So that's going to be something that you need to keep in mind, that there is going to be a level of a difference between the accuracy and the results on those lower res, but it'll give you a broader picture. So solving at the lower res will save you some credits, and then once you're more mature in the design, then you can start to go to those higher res solves. And also, the other thing that I learned is validation of the changes. Now, I thought the initial shape was pretty good, but I didn't make it to be like a supercar, right? To like cut through the air. I made it because visually it was kind of what I was going for. I wanted the hard lines, I wanted the shape. And ultimately, I could have made more changes to make it much better, but the changes that were made that, like dropping the nose a little bit or rounding the corners off, those changes were still mainly in line with the design intent while increasing the performance. Now, it could have made it quite a bit different and got better performance, but the idea here was the look, and then performance was secondary, trying to get the performance to be better. But looking at this again now with the mirrors, changing the shape of the quarter panels could help, because now I've got this sort of this surface friction area here that wasn't there on the previous version, because it wasn't really red there because the mirror wasn't obstructing the flow. So these are all ideas to take forward, but again, validation based on those changes. Now, the final version that we have here, which is never going to be final, always be changes, mainly has the mirrors added. There were some little pieces added for additional downforce in the front, because version 7 had some lift in the front. And then I also took away the little pieces underneath that I had in version 7 because they were causing that lift. So removed those and added some little fins on the air dam to kind of push it down just a little bit, so that the forces were mainly balanced. So overall, the drag coefficient dropped to 0.3, and the front lift is a negative number, which means we've got some downforce. Rear is very close to 0, and then we have the the convergence at 4,000 iterations of the solve. All right, so overall, that's the general process. I know that this video's turning longer. It's going longer than I anticipated it, but that's just kind of how it happens. And so that's, those are my big takeaways from the project. That's what I learned going through this with AirShaper. And again, the final changes, or at least final to version 8. I will, in the description of this video, I'll include a link to this version 8 file. So if you want to take a look at it, play with it, if you want to put it into AirShaper yourself or make some changes, I will caution you that if you do go back to the original freeform body and make changes, there is a good chance that stuff will break. And I say that just because of the nature of the way that some of the surface tools work in Fusion. So for example, if you trim and you select the area, the side of the model that you want to trim away, sometimes when it goes through the rebuild process, it flips those. So when I made any major design changes, what I ended up doing was rolling the history marker back right after the freeform model, made the changes, and then I slowly worked my way back through the model, like 10 features at a time. So if you want to do things like add a big spoiler or arrow or whatever, those are much easier to do after the fact. So just do it at the end of the timeline. If you want to try to make drastic changes to the shape, then I would just say, be careful, roll the timeline all the way forward to here, make changes and so on. But I'll leave that in the description of the video. You can play around with it. Some other things I'll put in the description of the video is like the original story behind why AirShaper started. It's a pretty interesting story about the founder, Wouter, who has been the technical expert that's been helping me and giving me options and so on. And so there's a story about the development of his concept car and the idea behind, diverting the air based on lateral forces and so on. So pretty interesting. And then with that, the sample report, I'll put a link to that as well in there for his vehicle. And he has got a whole video on it too. So if you go to the tutorials or the learning section, there's a whole video about this car, about the results from this car, and what could change and so on. So it's a pretty neat idea, a pretty neat concept on diverting the flow. And the report is there, the story is there. I'll put all that. Again, the link to the vehicle that I've used for all of this, I'll put that in there as well. All right, so the last thing I really want to talk about in this video is going to be the price. Now, price is a big one. And again, I know the core of this channel is going to be hobby users that are trying to learn something. We do have a lot of users in the professional sector, so people that use SolidWorks or use Inventor or use these more pro tools. And I say that as Fusion is a pro tool. I use it for professional consulting work all the time. But the price point and the fact that it has a hobby license version does put it in kind of a different category. And so when we look at tools like this, like AirShaper or like Quick Surface Lite and Quick Surface Pro and so on, where you're starting to get into spending thousands of dollars for your software, it's a slightly different jump. And so when we looked at SimFlow, and why don't I go ahead and I'll just bring up SimFlow pricing as well. I'm not very prepared for this video. All right, let's do SimFlow pricing. Last time I checked, I think it was like $8,000 a year. Yeah, so it's coming up in euros because I'm on a private browser, but 8,000 euros or roughly $8,000 a year for the professional version and 10,000 a year for the enterprise version. Right. So when we're comparing this, and again, the free version when we used it had a limit to the number of cells. There were other limits as well. So the mesh size was limited. So you could only do so much based on the geometry. Doing a full car in the free version would be nearly impossible unless it's like a Lego block car, right? So doing something in a free version of SimFlow for a full car, it just wouldn't work. And there are other options out there that use OpenFOAM in the back end. But just again, to level set pricing, $8,000 to $10,000 a year. It's a subscription service. When you look at something like SolidWorks, now a professional license of SolidWorks is going to cost you about $8,000 to get started. And that's because you're looking at the price of the license and the fact that you have a 2-year maintenance contract that you have to pay for ahead of time. And then it's roughly $1,500 to $2,000 a year for maintenance. That is just for the CAD software. If you add simulation with CFD, you can easily double that because there are all these different additions you need if you want materials package and so on. And then that also increases your yearly maintenance costs. So if you're just getting into it and you're looking for a CAD package and a simulation package, and you go into SolidWorks, you're probably going to be spending $16,000 to $18,000. Now, I don't have current numbers on that, but when I bought my current SolidWorks license a few years ago, it was just about $8,000 for the middle tier license. So not the lowest license, not the premium license, but the pro license. So again, just kind of level set these numbers when you're trying to say, okay, well, $2,000, $3,000 a year seems like a lot. But when you look at SimFlow, or if you go to Ansys, or you go to these other companies and you look at their simulations, most of them will be a pretty heavy initial investment, and most of them are going to be solving locally. Now, there are some versions of some of these software packages that offer a learning edition or a token or credit-based version of it, where you've got something similar to AirShaper, but you're basically paying in to get a certain number of credits to solve. And so that's something to keep in mind as well. But in terms of all the CFD software packages I've looked at, none of them have been at the price point that AirShaper is, nor have they been as easy to use. And I know I'm sounding like a salesman, like I'm trying to get you to buy it, but cost and understanding what you have available to you is something that is often hard to figure out when you're looking at these different pieces of software. And so when we look at the different plans, you've got 3 options, basically. You've got Discovery, which gives you 25 credits. Keep in mind that a medium resolution solve is 10 credits, and those basic solves are 1 credit, right? So if you're just doing basic solves, the lower resolution, then you can do 25 of them. If you start to add things like design advice, or consultancy, right, that's going to start to eat up some of those credits. So again, if you're doing basic accuracy simulations and you just want to review the results online, you can get 25 solves for roughly $1,000 a year. If you're going to be doing more with it, the professional one really makes a lot of sense. It is, 3 times the price, so you're talking about $3,000 a year. You get 100 credits with that, but you do get the design advice options, which again use credits, but that does things like. Let me go ahead and I'll just go back here. So this one I had, this one I had design advice turned on. And so what this allows us to do is look at a model and it says, okay, well, if I want to reduce drag, I need to move this red section here outward. I need to bump it up. And that's because it's kind of like a flat spot. And so what's happening is when the air hits the front of the car, it's going over that and then reattaching to the car. And so if I move those sections outward and make that transition smoother instead of, more flat, as kind of like a little dip there, then that will help me reduce the drag. And kind of the same thing with these blue areas, right? So I mentioned that I rounded this off based on the feedback I got from Wouter. And so if I want to, I can move that section inward to round it off, which will also reduce the drag. And so you get this design advice. It's going to cost credits, and it's typically based on the resolution of the simulation that you're solving. And so you can do things like reduce drag or increase lift, increase drag, reduce lift, and it will give you the output for that. All right, so that's a nice option that you have is getting that design advice. This does open up higher resolution, so this one's basic only, that 1 credit. This one does open up those and some more pro features. And so during the setup process, and actually I'll just go ahead and let's see. I'll just toss something in here so we can see it, if I can find it. Again, I am not very prepared for this. All right, so we're just going to do basic analysis. Again, you can use optimization. Again, it starts at 5 credits in internal flow. Now, if we go to set up the simulation, so these advanced options come into the enterprise plan. You can see I don't have access to them. But during the setup process, there are some more options where you can kind of tweak and get away from the default settings. But for us, it's going to be air, on the ground, moving, 100 miles an hour. Nope, 100 miles per hour. The rotation, this is based on the CAD model. So again, depending on where your X, Y, and Z is when you start to design, in most cases, it'll have to be rotated 90 degrees because when we look at like a side view in CAD, the X orientation is going to be different than what we see here. And so that's all that it takes for the setup. You can see that it's still processing the model depending on the complexity of the model. This generally just takes a couple minutes, so I'll keep talking while this happens. But the point of this is that to start to unlock and enable some of these more advanced options, you typically go up in settings. So for us, wheels, we can pick the wheels that we want. It also does this automatically. So if you just kind of let it go, it can figure that stuff out for you, or you can just pick them yourself. Once it's done processing, it is going to rotate them with the ground. We can say done. Oh, no, let's go to wheels. It also picked the whole thing. We'll just trash that one. We'll call it done. It's going to rotate it again. All right. So now we got that. You see there's a beta setting in here for ride height, flow openings, propellers, radiators. So all of these things, so like flow openings, for example, these can be used for flow into and out of areas, radiators. We can add, again, I'm not to that level on this concept, but you can add those as well. And then when you go to the next stage, you kind of pick all of the extra settings that you want. So again, design advice is going to be based directly on the simulation accuracy. So if we go to basic, design advice is 1 credit. We go to regular, it's 10 credits, and so on. And so again, when we look at all of these different options, and I'm going to go back to the plan. So we look at all these different options. As you go up to the professional or enterprise level, you start to unlock some extra things you can do. And you can see here that when we go to professional level, you get access to that consultancy. Again, it's 10 credits. You have 100 to use, but then you can use 10 to get that direct one-on-one feedback. Now, when you go to the enterprise level, this opens up a little bit more in terms of functionality. So you can now have multiple users using it at the same time. You also have the morphing option, which again allows it to adjust the shape for you. You get those higher resolution settings, which again are going to cost more credits, but you kind of go up in level. So if you have a fully detailed vehicle, for example, like a grill with a lot of detail and trim and all these other things that you need to include, then you need to go to those sort of higher levels. So again, that's kind of the basic setup of these different plans. If you happen to run out of credits, so let's say that you are on the Discovery, roughly $1,000 a year, and you run out of credits, basically what you do is you buy it again. So for another 25 credits, you pay another $1,000. I think the requirement is that you can buy half of that. I don't know how that works with the 25, but essentially instead of paying $1,000, you'd pay $500 and you'd get half of that, right? You get 13 credits or something. And it's the same thing with professional. So instead of $3,000, you could spend 1,500 and get 50 credits and so on. So you're not buying software like you are with Fusion and then adding additional things to solve simulations like tokens or cloud credits. But what you're doing is you're just buying into the whole thing. So the price that you see here is essentially broken down by credit. So that's the whole thing. That's everything. What I will say again, and I mean, I can't stress this enough, is if you are looking to do simulation, I would at least give it a try and just see how easy it is. If you've used anything else, if you've used SimFlow, if you used SolidWorks, or if you use ANSYS, then you'll just know that the setup process is much more difficult on those other programs. And you really need to have a much higher level of knowledge in simulation to make that work. If you're a novice, you're just getting started, or your focus is really on aero, cars, motorcycles, planes, things like that, then this has a lot of benefit, at least to get started on the discovery plan, to play around with it and figure out if it is the right solution for you. I have had nothing but good things to say about AirShaper. I've used a lot of programs over the years. I still use Fusion, obviously. I use Plasticity. I use SolidWorks. I use Inventor. I use Blender from time to time, and I use other things as well that I don't cover on this channel. And all of them have pros and cons. Everyone has pros and cons. There are things that I don't like about Fusion. I actually have a video that I started about things I wish worked better in Fusion, which I may or may not release. Inventor, SolidWorks, all these programs have their pros, they have their cons. With AirShaper, I haven't really found any cons yet. Now, I've only been using it for the last month or so I'm going to continue to play with it. I have plans to do a scan of the GPZ project with me on it, and I will try to do a simulation on that. If you all want to see that, leave a comment, and I'll make sure to include it in a video. It's going to be for my own personal use and kind of some of the design, so I don't necessarily plan to do an entire video on it, but if you want to see it, I can always include that and do that. But I'll continue to play with it, and if my idea or my inputs change, I'll let you know. But for the most part, anything that I show on this channel, I use and I back, whether or not it's an affiliate or I'm getting paid to do it or not. This is something that I feel strongly about, and I've had lots of companies reach out, programs reach out that I have not done just because I don't use them and I don't like the way that their UI is set up, and I don't like certain things like that, which is I don't do a lot of SolidWorks videos because I don't really love the UI and the UX of it anymore. So with all that said, hopefully this video was helpful. It turned out to be quite a bit longer than I thought it would be. But again, in the description of this video, I'll put the original story behind how AirShaper got started. I will leave a link to the demo for this concept car so you can kind of look through that report. I'll leave a link to the Fusion file for this car if you want to play around with it. Again, with those warnings that if you are going to adjust the shape, make sure you roll the timeline back. You're going to have to kind of piece through it because it is, 8 concepts deep now. There are a lot of different things and changes that I've made over time. As you go through, other forms are things like the ducting that goes through and some additional aero and some spoiler at the rear, things like that. So these are all throughout the timeline. Most of the body design changes were done with forms. However, this was done with surfacing. So if you want to play around with, some of these things, then you're just gonna have to find it in the timeline because I didn't do a design video on it. But with all that said, if you're still with me, if you have any comments or questions, please leave them below. If you want to see more simulation stuff, let me know. I don't currently have plans to do more simulation in the near future. There's a lot of scan data videos that we've got coming. We're still working on the CAM course for learneverythingaboutdesign.com, and there's just a lot of back videos that people have requested that I'm going to try to work through before the end of the year. So the simulation stuff is probably a little ways off, but if you have any comments or questions, I'll do my best to answer those. If you want to see more of AirShaper or simulation, let me know, and I'll make sure to keep that in the list. But as always, thanks for watching, and we'll see you in the next one.